Welcome to myprojectbazaar.com. Our project title is an IoT notation-based authentication and key agreement scheme ensuring user anonymity for heterogeneous ad hoc wireless sensor networks. Abstract. A number of industrial IoT projects has been conducted in areas such as agriculture, food processing industry, environmental monitoring, security surveillance, and others. Meanwhile, the number of IoT publications is quickly growing. IoT aims to connect different things over the networks. As a key technology in integrating heterogeneous system or devices, SOA can be applied to support IoT. In this process, we present a new signature-based authentication key establishment scheme for IoT environment. In this project, we will develop in Network Simulator 2. Finally, we calculate the proposed method result like packet delivery ratio, delay, energy, consumption, throughput, and the network lifetime done by Network Simulator version 2. All these processes are implemented not by using base paper, which is a concept wise only, which is in the flow diagram. Let us see the flow of our project. This is our project flow diagram, which firstly have to identify the network. So our network is heterogeneous ad hoc networks. In that network, first we have to form the packet informations. In the registration phase, we have to authenticate the process for sending the packet. If the authentication is successful, means it will be sent the uplink handoff phase. That is, if any node is wants to send the data to the destination, means the authentication process is done and the uplink handoff phase is done, because uplink handoff is nothing but the information passed from one network to another network. So in that we have to search available channel to destination. For downlink handoff phase, we have to verify the process of broadcast acknowledgement. That is, the acknowledgement is sent by the downlink process. Finally, we have to analyze our process with packet delivery ratio, delay, throughput, and all. Let us see the output of our project. For running our NS2 process, we have to open the VMware workstation. So this is our VMware workstation. So now I am clicking this terminal window. So we have to run our process in command line only. So I am going to change our directory to our code folder. So this is my code folder name, and type ns space main tcl for running our main file. So this will print the RSA key algorithms and the position of each and every nodes in XY format. So this is our output window called the NAM network animator window. When we click on this, play forward means it will be works. So I am give the speed as 20 ms. This is the structure of our heterogeneous wireless ad hoc networks. So these three are nothing but the doctor, home user, and the industrialist informations, and these are all the heterogeneous network users. This is the one IoT is the server for each and every these things. So this is called as a centralized server. So we have three types of networks such as Wi-Fi, WiMAX, and the LTE network. Now the data connection between the one network and another network is run on parallel manner. So these doesn't give any delay. So now the data transmission between the node 4 with the IoT server is done. So this, when I clicking this drop dial, means that data connection and how much bytes sent information is printed here. So 1618 bytes of information is transmitted from 4 to the IoT server 3. Parallelly, the data communication packets from 21 to 20, there is 21 to IoT server 3 is sent. So all the processes are in a random mobility model. Now the data transmission between the sensor node and the industrialized node and the doctor node will be done here. So the data transmission is done via using our NS2 simulator. So now I am going to run our graph file. So our graph is implemented by using xgraph. For that, type xgraph space delay.xg for running our delay graph .xg. So this is our delay graph. So delay of our proposed RSE algorithm and the protocol process. Now I am going to run our packet delivery ratio graph. So this is our packet delivery ratio, and next graph is energy.xg. So this is our energy graph, how much energy consumption details is displayed here, and finally the graph is THR throughput.xg. So we have to identify MPPS of, so number of packets sent at a time is displayed here. Thank you for watching.